In this video, I will be talking about measuring and classifying angles. Before we get there, I want you to recall two things. The first is the ruler postulate. This says that points on a line can be matched one-to-one with the real numbers, basically meaning that we can measure segments of a line and find distances between points. The second is the segment addition postulate. This says that if we have line segment AC and B is between A and C on the same segment, then the distance AB plus the distance BC is equal to the distance AC. The reason these two things are important is because two very similar postulates occur with angles. So to start, what exactly is an angle? An angle is two different rays with the same endpoint, as shown here. This is angle CAB, where A, the endpoint, is called the vertex, and both rays are called sides. So when we name angles, we always have the vertex in the middle. So for this example, we have three different angles. We have angle WXZ, which is the bigger angle. We have angle WXY, which is the top angle. And then we have angle YXZ, which is the bottom angle. Again, the vertex is always going to be the middle part when referencing an angle. You can switch, so YXZ can be considered ZXY, but the same thing is true. The vertex has to be the middle letter. So what can we do with angles? The first thing we can do is measure them, just like line segments. And just like the ruler postulate, the protractor postulate says this. So consider a ray OB and a point A on one side of OB. The rays of the form OA can be matched one-to-one with the real numbers from 0 to 180 degrees. The measure of AOB is equal to the absolute value of the distance between the real numbers for ray OA and ray OB. This means that the measure of AOB is the difference between this point right here and this point right here. So in this case, the measure of angle AOB is about 130 degrees. Different measures of angles have different classifications. Angles can be less than 90 degrees, as shown right here. These angles are called acute angles. Angles can be equal to 90 degrees, which are called right angles, and are always denoted with the little box. Angles can also be greater than 90 degrees, which are called obtuse angles. And angles can be equal to 180 degrees, which are called straight angles. So for example, if we want to find the measure and classify the following angles, we can do so with these measures and these names. So angle KHJ, that measure looks to be about 50 degrees. 50 degrees is less than 90 degrees, so this is an acute angle. The next angle is LHJ, which goes through 90 degrees, which means it is a right angle. Angle GHJ goes through 180 degrees and is a straight line, so this is 180 degrees. and it is a straight angle. Angle LHK is a little bit trickier. The ray HL goes through 90, and the ray HK goes through about 50. So this angle measure is 90 degrees minus 50 degrees, which is equal to 40 degrees, which again is less than 90 degrees, so this is an acute angle. The next thing we can do is add and subtract angles, just like segments. The postulate that lets us do this is the postulate 4, the angle addition postulate. So if we have point P in the interior of RST, then the measure of RST, the bigger angle, is equal to the sum of the measures of RSP, the top angle, and PST, the bottom angle. So in math notation, this says that the measure of angle RST is equal to the measure of angle RSP plus the measure of angle PST, all color-coded for you. So for example, if we have this figure and we know that the measure of the bigger angle, LKN, is 145 degrees, and we want to find the measure of angle LKM and the measure of MKN, we can do so by using this postulate. So we know that the bigger angle is 145 degrees. This bigger angle should be the sum of the two smaller angles. So this should be the sum of angle LKM and the measure of angle MKN. And from that, we can just substitute. So 145 degrees, the measure of the bigger angle, should equal to 2x plus 10 plus 4x minus 3. From there, we can combine like terms. So 145 degrees is equal to 6x plus 7. And now we just solve it like a normal equation. So we can subtract 7 from both sides. So we have 138 is equal to 6x. So x is equal to 23. That doesn't answer our question though. We want the measure of LKM and the measure of MKN, not just x. So then we have to substitute x into each of these expressions. So the measure of angle LKM is equal to 2x plus 10. And now we know x. So this is 2 times 23 plus 10, which is equal to 46 plus 10, which is equal to 56. So the measure of LKM is equal to 56 degrees. And we can do the same thing for the measure of angle MKN, which is equal to 4x minus 3. Again, we know x now. So this is 4 times 23 minus 3. So 86 minus 3, which is equal to 83 degrees. You should note that this figure is not to scale. Another example uses the classifications of angles. So for this, we have that angle EFG is a right angle, as denoted by the little box. And we want to find the measure of the two smaller angles. So the measure of angle EFG, the big angle, is equal to the measure of angle EFH, the top angle, plus the measure of angle HFG. So then we can substitute what we know. We know that EFG is a right angle, so that it's equal to 90 degrees. We know that the measure of angle EFH is 2x plus 2 degrees, and the measure of angle HFG is x plus 1 degrees. Again, from there, we're just solving for x. So 90 is equal to 3x plus 3. If we subtract 3 from both sides, we get 87 is equal to 3x. So 29 is equal to x. Again, this isn't our answer. This is part of our answer, but not our entire answer. From here, we have to substitute x into both of these expressions. So the measure of angle EFH is equal to 2x plus 2 degrees, but now we know x, so it's 2 times 29 plus 2. So this is 58 plus 2 degrees, which is 60 degrees. Then the measure of angle HFG is equal to x plus 1 degrees. So this is 29 plus 1, which is 30. We can check this because 60 plus 30 should equal 90, and it does. The next thing we need to talk about is the congruence of angles. And angles, just like line segments, are congruent if their measures are the same. So in these two figures, angle A is congruent to angle B because the measure of angle A is equal to the measure of angle B. You can also say that angle A is congruent to angle B. Keep in mind that measures are equal, angles are congruent. An angle bisector is a ray that divides an angle into two angles that are congruent. So in this figure, the measure of angle ABC is cut in half by ray D. This means that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. But it also says that the measure of angle ABD is equal to the measure of angle DBC because this ray cuts the entire angle in half. For example, if we're given this figure, angle ABC or ABD with ray BC, and we know that BC bisects angle ABD, and we want to solve for x, then we have to set up an equation. So because ray BC bisects angle ABD, we know that the measure of angle ABC is equal to the measure of angle CBD. From there, we just substitute what we know. The measure of angle ABC is 20 degrees, and the measure of angle CBD is 3x plus 5 degrees. From there, we just solve like a normal equation. So we subtract 5 from both sides. We get 15 is equal to 3x. Then divide both sides by 3, and we get 5 is equal to x. So as a recap, here's everything we went over. We went over what an angle actually is, which is two rays with the same endpoint or vertex. We classified angles. Acute angles are angles less than 90 degrees. Obtuse angles are angles greater than 90 degrees. Right angles are angles that are 90 degrees. And straight angles are just straight lines. From there, we went to the protractor postulate, which just says that we can measure angles. We also covered the angle addition postulate, which says that an angle is the sum of its parts, and then we did some examples, and then we went over angle congruence and angle bisectors. And this is all there is to measuring and classifying angles.